ኦኬ ሶ ስንጀምር እንግዲህ ትላንትና ካቋረጥንበት ነው የምንቀጥለው። ሶ ትላንትና ደግሞ ያቋረጥነው ከምንድን ነው? ስትራክቸሪንግ ሪኳየርመንትስ። ሶ የተወሰነ ነገር ለማየት ሞክረናል ትላንት ስለ ሰርቨር አርኪቴክቸር ምናምን። ዛሬ ደግሞ ስለ ስትራክቸሪንግ ሪኳየርመንቶች ነው የምናየው። ሶ ታይፕ ኦፍ ሪኳየርመንትስ የምንላቸው ነገሮች አሉ። ስለዚህ የመጀመሪያው ነገር ምንድን ነው? ዩዘር ሪኳየርመንት አለ ኤንድ ሲስተም ሪኳየርመንት ኤንድ ሶፍትዌር ስፔሲፊኬሽን እንዲሁ የሚባሉ ነገሮች አሉ። ስለዚህ statements, I mean user requirements, statements in natural language plus diagrams of the service the system provide and its operational constraints written for the customers. Customers are users. So, and system requirements uh, a structured document. It is a structured document setting out a detailed description of the system services written as a contract between client and the contractor. So we can use it as an example of written contract to the between the clients and the uh, the contractor itself. And software specification, a detailed is a detailed, structured, detailed software description, which can serve as a basic for a design or implementation. So it's written for developers. Okay. Okay. Written for developers. Uh, what software specification is for developers and service service uh, requirement system requirement is written is a contract, it is contract based, and also functional and non-functional requirements are very huge in this topic. So functional requirements are the statements of services that the system should provide, is the function of the system. So how the system should react to the particular inputs and how the system should behave in a particular situations, such as calculations, such as um, interaction like data inputs and output. So, and the other is non-functional requirements are requirements that constraints on the services or the functions offered by the system, such as timing constraints on the development process standards, and etc. So the domain requirement, there are the domain requirements required that that uh, common for the application domain of the system and that reflect characteristics of that specific domain. And functional requirements describe functionality or the system services depending on the type of software expected users and the type of system where the software is used. Okay, so the functional user or the functional requirement user may be a high level statements of what the system should do, but functional system requirements should describe the system service in detail. As an example of functional requirements, we can take that the user shall be to search either all of the initial sets of the database or select a set subsets from it. So This is a functional requirement because the user can search, it can able to search. So yeah, searching function is a functional, one of the example of functional requirements. And also the system shall provide appropriate viewers, uh, appropriate viewers for the user to read documents in the document store. And every order shall be uh, allocated a uniquely identifier, or the order ID, which the user shall be able to copy to the account's permanent storage area. So these are some of the requirements. And also requirement is completeness and consistency. This is a big one. So in principle, requirement should be both a complete and consistent. When we say complete, they should include description of all facilities required uh, to run the system. And when we say consistent, there should be no conflict or ambiguity or contradiction in the description of the system facilities. So the requirements must be complete and consistent. In practice, it is impossible to build a complete and constrained requirements document. It is impossible, but it is, you should have a good practice with it. And also the non-functional requirement is define system properties and constraints like reliability, response time, the storage requirements, uh, and the speed, the memory size, uh, capabilities of input output devices, and the system representation, etc. So these are non-function of the system that we build. Okay, so those are a non-functional requirements to run the software, okay, or the system. So the process requirements might be also specified, uh, mandating a particular case system, programming language, or development methods. So these all are non-functional requirements. Whether you build the system on the Java programming language, or whether you build it on C++ for speed, maybe for fast production you might be use Python, or this should be not included in functional requirements, but it's non-function of what you build of the system. And non-functional requirement may be more critical than the functional requirement. Obviously, why? Because uh, after you build the software, you need to run it on some computer or some system. So that system must be meet in order to run the software you intended to uh, build. So in order to run the software, you need a complete, full capable systems to run on the system. So you have to, it's and sometimes it's more critical than the functional requirements, because you can't run your system on the air of. So if these are not met, the system is useless. As you can see, you can't run the system without the non-functional requirements of the system that might be included in CPU storage, for example. if you don't have enough storage to run the software, the system you build, you can't run the system. So it's basically useless. So these are non-functional requirements diagram. So the non-functional requirements are on the top. So then the product requirements and the organizational and external requirements are down to that node. And also on the product requirements, there is efficiency, reliability, portability, and usability uh, requirements. So when we say efficiency, we have the performance and the speed as an example of requirements should be taken care of. And also on organizational requirements, there is a delivery requirements, implementation, and the standards. These are organizational requirements. Okay, if it is standardized, it is non-functional requirement and included on organizational requirement section. So there is another external requirements on the non-functional requirements, which is can include ethical requirements, uh, legislative and interpolitility, interoperability requirements. So in legislative requirements, there is a privacy and safety requirements. So it is the most important part of the non-functional requirements. It's very good. So non-functional classifications. As we see earlier, there is a product, organizational, and structural requirements, and on the product requirements, there is specified that delivered product must behave in the particular way. For example, the execution speed and reliability, etc., the performance, etc., must behave uh, on the particular way as the product requirements defined. And also on organizational requirements which are consequence of the organizational policies and procedures. It must be follows. Example, process of standard used, implementation requirements. These are all on the organizational requirements. And also there is an external requirements that arise from factors which are external to the system and to the organization itself. So its development process. For example, the interpoliticity requirement is legislative requirement is that deal with some policies and other stuff other than the organization. And also on the product requirements, it shall be possible for all necessary communication between the ASAP, PSE, and other user to be expressed in the standard ADA character set. An organizational requirement system development process and deliverable documents shall conform to the process of delivery defined in this standardization. And external requirements shall be not disclose any personal information and customers apart from their name and reference number. So this is included in the privacy section. So there is an exercise here. The system shall be available in English, Spanish, Amharic, etc. languages. So this is uh, not functional requirements, but it is so organizational requirement. So this be non-functional requirements. Okay. And other exercise, the system shall always the user to search from. This is searching functionality by authors in title. So this is functional requirement. And also the system shall provide a list of all previously ordered books. So this is also functional requirement. And this, okay, so the system shall support minimum 100 transaction per hour. So this is a performance. So this is non-functional requirements. And other than the system shall be available to all users 24/7. This is non-functional requirements also. Okay, so it's reliability and other stuff. The system shall always allow the user to remove its functional requirements. There is remove add functionalities. So to the system e-commerce, let's say the e-commerce shopping cart, you can add and you can remove any product. So this is non-functional, I mean functional requirement. So uh, that's for requirements, highlights, and the other thing we must do is this: the use of models. Models. What are they, and how to use them? Let's discuss on that. So this is a sandwich, which is awesome, and now the time is almost 9 a.m. 9:40, and I haven't eaten my breakfast yet, so I'm so hungry when, especially when I see these kinds of food. So requirements modeling, elicitation or gathering information and analytics, and modeling are intermixed here. So the first, don't show this image to me right now, especially requirements layers and model layers. Then requirements layer, that after you have a modeling layer. So this is intermixed structure. So requirements on modeling, this is an essential task in a specifying requirements. So there is a map elements obtained by the illustration to a more prices from. So help better understand the problem, help it helps find what is missing or needed further discussion, and different modeling languages, and also information natural language. There is GRL, goal-oriented modeling, which is great modeling, and functional modeling. There is a functional modeling. We call it UML, or unfined unified modeling notation. Unifying modeling notation, and functional modeling, SDL, specification and description language, SDL. So logic like ZBDM, which stands for VENA development method, and UCM, use case maps, So I have to, okay. Then model. What is model? So when we come to model, a model is a reduced representation or simplified abstract of one aspect of a system used to help understand, communicate, and direct. by when you say help and understand complex problems and or solutions in order to it help us to understand. And other is the communication part is the information about the problem and solution. And direction or direct is when we try to implement this model. So the model is a reduced representation or simplified abstract of one aspect of a system, one aspect of the system. So a small representation, uh, reduced representation of the system that can help us to understand, communicate, and also implement this system what we are going to build. And qualities of a good model qualities are first abstraction or abstract, understandable, accurate, predictive, and inexpensive in terms of maybe money, time, and development costs, etc. So the modeling structure, there is modeling structures so that the concept of entity and their relationship. Okay, so used one of the following notation like ERD, entity relation diagram, the traditional version, UML, it's a class diagrams, and the relational tables. So these are the concept of entities and the relationships of the structural modeling. So, so it can be used. This can be used for the following purposes. So, model of the problem domain called the domain model. So that the two versions are existing and to be. Okay, and the model of input and you output data structure of the system to be so, and other is model of the stored data or the database, model of the stored data or the database. Okay, is not necessarily an image of the domain data, and additional data is introduced. For example, user preferences. These are the example of use case of model. And the architectural design of the system to be, we can refer as like that. And when we come to modeling input and output, the nature of input and output related to the problem, the data, additional data related to the solution, and promote the user, odd options, error messages, and etc. Collect in a data dictionary using plain text, EBNF, code like notations, logic, structured charts, and etc. And graphical output, it can include screens, forms, iconic representation, drawing, prototype screen, and or forms printouts produced by uh, operational prototypes. So modeling have dynamic behaviors modeling techniques, the text plane and the function system use in the use case. So discussion tables, activity diagrams, use case maps, and finite sets, machines, and etc. So simple state mechanism, we call it finite state mechanism, is a simple state mechanism used two state diagrams or transaction table notations, and extended state mechanism. Uh, so the UML, Unified Modeling Language, states much including SDL. So these are the basic ones, and also the requirement validation and verification. Okay. So this needed to be performed at every stage during the requirement processes. On the process, we mean when you gather the information, which means illustration, on the illustration process, when you analyze, and when you define the specification. On this, you have to verify, and you must validate your processes. So this is at the end of chapter 2. We will continue on the next chapter, which is a great topic. The great topic. So let's end this now.